Hi, do you know what is the most embarrassing number for scientists in physics? Like, what is the biggest difference between what scientists have theorized versus what instruments have observed and reported back? It is 10 raised to minus 120. Imagine your theory going off by a factor of trillion times another trillion. Not once, not twice, that is 120 times over. That's not a mistake, that's a crisis. 10 raised to power of minus 120, the single most embarrassing number in theoretical physics. And to find its origin, we'll have to look at the energy of nothing, energy of vacuum. Okay, let's rewind a century. It's 1970, and Einstein is perfecting his masterpiece, the theory of general relativity. But there's a problem. His equations predict a universe that's either expanding or contracting. And back then, everyone, including Einstein himself, believed the universe was static. It was neither expanding nor contracting. So he takes his equations by adding another term, the cosmological constant, denoted by Greek letter alpha. It's a repulsive force that is built in the universe itself, a kind of anti-gravity that keeps the universe in balance. Now fast forward to 1920s, Hubble observes the galaxy moving away. Einstein reportedly called alpha his biggest blunder. And decades later, astronomers studying distant supernova discovered something shocking. The universe wasn't just expanding, it was accelerating. That repulsive force, the cosmological constant, it was real, it was no blunder. Okay, let's discuss about this vacuum energy. It sounds pretty weird that vacuum would have energy, and that too, that will have the universe expanded. Take any cubic meter of space, right? What would you find it? Maybe stars, planets, dust, gas. Take them out. Okay, take stars, planets, any visible matter out of it. What would be left? Maybe dark matter. Take that out. What should be left is true vacuum. But really, no part of space is truly vacuum. There are particles in it. And these quantum particles will wiggle a little bit. They'll keep shifting. Why? Because of uncertainty principle. One can never truly know the position and the spin of any quantum particles. They're always moving, or in terms wiggling. And due to this wiggle, it changes the electromagnetic field. And that electromagnetic field, when it interacts with other fields, they generate virtual particles. And those virtual particles give energy to vacuum. And how much energy does it give? Depends on how fast it is popping in and out of existence. Now this equation gives the energy given by virtual particles when they come in and out of existence. Now this is how Higgs gets mass, and this is how vacuum space gets energy. Now think of a small space. Like, how small can you think? Maybe a width of electron. Okay, so if you take this space as big as the width of electron, how much energy would it have? It will have 5 trillionth of a joule in one of those little spaces. But if you take this space as big as the cup of coffee, that cup of coffee will have enough energy to boil all the oceans on planet Earth. But why stop here? We can even shrink it down. Edge of experimental physics now lies at unfathomably small space, 10 raised to minus 19 meters. And if you do the mathematics, it turns out that every cup of coffee would now have enough energy to blow up entire planet, and it could do this 100 billion times. Means every planet in this galaxy, Milky Way, can be destroyed with as much energy as in a cup of coffee. But why stop there? If we go to the theoretical limit, which is Planck's length, the time taken by light to cover Planck length would be 10 raised to minus 42 seconds. That works out to be the theoretical energy in vacuum to be 10 raised to 113 joules per cubic meter. Let that sink in. That's more energy than a trillion hydrogen bombs in every cubic centimeter of space. But when we actually measure the universe through cosmic acceleration and supernova redshifts, we find that the observed vacuum energy, the rate of expansion of the universe, to be 10 raised to minus 9 joules per cubic meter. If you take the ratio of theoretical value versus the observed value, the difference turns out to be 10 raised to 120. That means our best theory of empty space is off. It's off by a factor of 120. That's worst theoretical prediction in the history of science. It's not just wrong, it's cosmically wrong. And we call it the vacuum catastrophe. Physicists have tried everything to fix it. Some hoped that supersymmetry, a theory that balances bosons and fermions, would cause the quantum contribution to cancel out. But till now, LHC, Large Hadron Collider, found no evidence of it. Now, others have invoked multiverse theory. Maybe there are countless universes, each with different vacuum energies. And we just happen to live in one where energy is just right for the stars and galaxies and life to form. Now that's anthropic principle, not because it's fundamental, but because we are here to ask. So that tiny number, 10 raised to minus 120, might not be a mistake. It might be a clue, a glitch in the code, pointing us to a deeper theory where, gravity and quantum mechanics are no longer enemies. A theory of everything. Till the time we find the theory of everything, we're left with staring at this number, 10 raised to minus 120. It's the way of universe saying, nice try humans, but you're not there yet. Thanks for watching.